Okay, so hello, thank you for joining me today. My name is Angelina Kovacs. I am a PhD researcher, currently working on cybersecurity on data spaces. And I'm working on Ikerlan, which is a research center located in the Basque region in the north of Spain. So in this presentation, we are going to explore how DAG-based distributed ledger technologies can be integrated within the international data spaces architecture. This work has been done with my colleagues Jorge Lanza from the University of Cantabria and Leticia Montalvillo and Aitor Rubieta from Ikerlan. So to begin with, let's imagine we are a data owner and we have different industrial machines generated vast amounts of data. And we first want to store that data in a data storage system. But then we may think on explore the value of the data, to get value out of that data we are not using. And we may have an external data user who is interested in exploring that data and processing and analyzing that data. And for that, we have some requirements to meet in order to share data with an external entity. We first need to enable secure data exchange across multiple entities in different domains. We need to ensure data sovereignty. That means that me as a data owner of that data, I need to have full control on with who I'm sharing the data, how and under which circumstances. And for that, we need to enable data access, data usage control, and legal compliance. So to meet these requirements, we can make use of data spaces. So starting with the International Data Spaces Reference Architecture model under the 4.0 version, here we have the conceptual definition of different components, of core components to implement a data space. To begin with, we have the connectors, which is our gateway to enter the data ecosystem, right? But then we have some core components like the identity provider, which will help us to identify different participants and core and technical components of the ecosystem. Then we have the metadata catalog, where the descriptive features, usage terms, and other terms such as the pricing, we are willing to be paid for our data assets. So all of that is going to be kept in the metadata catalog service. And finally, we can have a clearinghouse, which will be in charge of recording all of the operation happening in the ecosystem. So our purpose is to implement all of those conceptual core components of a data space with a distributed ledger technology. And among all of the different types of distributed ledger technologies, we are basing our solution in the IOTA tangle and the IOTA technology. The IOTA tangle, which is the distributed ledger technology IOTA offers, is based on a directed acyclic graph structure. And that enables us to have incoming transactions confirming the transactions that are already in the ledger. And because of that structure, that helps us to have scalability, that our solution can be scalable. Also, IOTA currently has no fees to be paid for any transaction we want to keep on the ledger. And for that, we can have microtransactions. And all of this makes it a suite solution for industrial IoT environments. So as any distributed ledger technology, it will offer to our data space data immutability, data traceability, and data provenance. More specifically, in our solution, the IOTA tangle will enable us to have a decentralized identity management, will work as a verifiable data registry, and will further enable us to deploy smart contracts to automate different processes happening in the data space. So to start with the proposed solution, more in a technical level, we start with the connectors, the core components of the data ecosystem. So we are basing our solution in the Eclipse Data Space Components Connector, deployed as Docker services, and implemented the data space protocol. As for the distributed ledger technology, we are using IOTA tangle. We are deploying a private IOTA tangle under the Stardust version, And we are using one for the control plane of our data ecosystem, but for the data plane, we are also using it to store data. But actually, any type of data storage system can be used, and it will depend on the data owner own architecture and own preferences. So to better explain our solution, we will have a look on the different processes defined for a data space, basing on the IDS-RAM specification. So the first one will be the participant onboarding, right? Every component and every participant in the ecosystem must be identified and authenticated in order to ensure trust in the ecosystem. So we are basing our solution in a decentralized identity management by implementing the self-sovereign identity concept with decentralized identifiers and verifiable credentials. And we are making this with the IOTA identity framework. Then we, as a data owner, have some machine data, and we want to publish all of the descriptive features of that data. And we are making it with a verifiable credential, where we will attach metadata description, usage policies, and for example, the pricing we are willing to be paid off. So that will be stored in a metadata catalog. And then all of these operations made by our data owner will be stored in the IOTA tangle via the clearinghouse components. And then on the other side, we have the data user, which is also interested in searching for some specific type of data. And for that, data user also has to be identified in the ecosystem. And once identified, he will search for data querying the metadata catalog. And also all the operations will be logged in the clearinghouse. So then, once our data user actually finds the data he wants, the actual contract negotiation process will happen between our connectors, our ADC connectors. Currently, we have found that this process is not completely implemented in the Eclipse data space components. Since nowadays, the data consumer has to accept the policies made by the data provider and cannot make counter offers and cannot actually negotiate the terms of the contract agreements. And for that, we are working on it, and we have come with a workflow or an algorithm yet to be implemented where we define threshold values attached to all the contract terms a data provider can define for its data. So in this case, the diagram is based on the state diagram proposed in the data space protocol for the negotiation process. And on the first example, we have that our data consumer offers some policies, but those policies matches completely the policies made by the data provider. But if we introduce some threshold values, actually our data consumer can make another offer with different values to the contract terms, and our system will also iterate on it and actually lead to a contract agreement between both. And also, if the policy does not match and it is not within the threshold values, then we have to make another counter offer and start the whole process again. And then once we have a contract agreement between the data provider and the data consumer, we then can exchange the actual data. So this process can be implemented between connectors or in any other form stated in the contract agreement. So for example, here, as we mentioned, that data is stored in the IOTA tangle as well, so our data consumer has to access the IOTA tangle to retrieve the data. But we have to make sure that the consumer is making a good use out of that data. And that means that policies are met. And if they are not met, we need to be notified. So for that, we need policy enforcement mechanism to enforce the correct use of that data. And we are also working on this by the implementation of different usage control tools and privacy enhancing technologies. So to end up with some details on the actual implementation of this small data space. So as said, the EDC, we are using the EDC connectors based on the minimum viable data space solution. As for the identity provider, we are implementing it with IOTA Identity Framework. As for the metadata catalog, in the early stages of the project, we are using a Mongo database, and we are implementing a central metadata catalog. But future efforts are to make it decentralized and to store data as triples to further enhance the query of data. And then for the clearinghouse, as the main goal of the clearinghouse is to authorize people to have a control on who can write or read from the distributed ledger, we are using the IOTA client framework for that. And also, we are implementing a secure payment system with IOTA wallet framework in order to proceed with the actual payment of the data offer when data is consumed. And as for the two distributed ledgers, as said, we are using private IOTA tangles under the Stardust version, implemented Hornet nodes. As conclusions and future work, so we have seen that we can actually implement core components of the IDS RAM conceptual frameworks, and we can make that with IOTA ecosystem solutions. And this differs from traditional blockchain-focused studies that also said that this can be done, but they are only focused on blockchain. And we have demonstrated here that this can be done using another types of distributed ledgers. And we have successfully deployed an identity provider, a metadata catalog, and a clearinghouse. And while this marks an advancement in secure, sovereign, and interoperable data management, exchange, and further exploitation in industrial IoT ecosystems. As future work, well, we still have to work on contract negotiation and ways on how to implement the workflow we have proposed with those threshold values attached to the contract. And we want to make that process automated with the deployment of smart contracts running on top of that distributed ledger we are using. Then we also have to work on the integration of different policy enforcement tools implemented, for example, in the connector, which will be the best options, that the actual data exchange will happen only between connectors, and the policy enforcement tool will be also integrated in the connector. And also, as said, we can achieve this with different privacy enhancing technologies, mechanisms. And then to further enhance interoperability in the ecosystem, we'll still need to integrate a vocabulary provider and a data provider that can offer different functionalities to process and analyze data. So that's all, and thank you for your attention.